Hello everybody, it's your Table Charles Besson. Welcome to another number system tutorial, and today we're going to talk about the ones and twos complement. Okay? Now what is the importance of this one and twos complement? This one and twos complement are very important in some cases of operation. I want to you that the computer works with the many one and zeros and use the basics not only for memory, but it works in most of this operation. Most of the operation the CPU is the ones and zeros. Now all those operations, however, they're only one operation. There was a secret that been hiding from me from the beginning. Very sorry, there was only one operation, which is the addition. The computer doesn't know multiplication, it doesn't know division, it doesn't know subtraction. Now, how does it subtract? How does it divide? How does it multiply? Now, in the previous videos, when we're talking about multiplication, division, you saw we're using mainly addition and also we're using the addition, right? And for division, we're using subtraction. And now, how does it subtract? So, this is where the one and twos complement come into the rescue. You see, let's just say the twos complement of a number, for us to have a represent a negative number, we need to use the twos complement. But in that twos complement is beyond the scope of this video. So the next number is beyond the scope of this video. In the next video, I'm going to use what we have learned here to represent negative number like negative 24, negative 36, and negative 13. But first, let's talk about the ones and twos complement. And I'll give you a very shortcut which you can use to have the one and twos complement within one line. And then, another thing is that you need to know that the twos complement of a twos complement is the number. Well, if you want to know, make sure watch it to the end and you find out. And if you are surprised or stunned by my proof, please make sure you give me a thumbs up. Okay? Well, without further ado, first thing let's do, you need to do that before you get this twos complement, you know how the ones complement. And I want for you to have the ones complement is simply having the reverse of each number. Now, zeros and ones are like voltages will have positive and negative voltages. So the one is simply the positive voltage and the zero the negative. So 1 is high and 0 is low. I will know that the opposite of high is low. So also you see 1, you reverse it to 0. And when you see 0, you reverse it to 1. So first we get the first complement. First complement, abbreviate it. We're going to have here 0, 0, 1, 1, 1. Now, when you go to the twos complement, you add a 1. Okay? Plus 1. So here, from the addition, which we know, we want to have 0 here, a 0 here, a 0 here, and a 1. Let me just add a 0 here. Okay, we get this. Let me just write this number somewhere and keep it. And for this purpose, let me just use a blow ink. So 0, 1, 0, 0, 0. That's the twos complement. Let me take this one example. Well, we have 1, 0, 0, 1, 0, 1. Well, the first complement is going to be 0, 1, 1. Yeah, 0, 1, and a 0. Now, to get the twos complement, we add a 1. We're going to have a 1 here. We're going to have still a 1, a 0, 1, 1, and a 0. Now, the shortcut which I'm going to give you is very, very simple. Now, the shortcut simply tells you this. Let's take this number, for example, where we have 1, 1, 0, 0, 0. Now, in this method, you move from the least significant figure, always give priority to the least significant figure. You move from the least significant figure to the most significant figure. See, when you see your first one, you don't invert. You see, you keep everything the same. See, when you see your first one, so here we're going to have as twos complement of this number is going to be 0, 0, 0, 1, 0. How do you clearly see that? Like here, when we also convert, we have this 0, 0, 1 here. But once we add a 1, it brings 0, 0, 0 to this place where we had the first one. It brings the 1. So when you're moving from this significant bit to the most significant bit, if you have all the zeros, you keep a constant. When you made the first one, then you keep when you made the first one, you keep it constant. From there, you begin in protein. So let's take the second example first. Well, let me give you kind of little challenge. Let's pause the video, come back, and check my solution. And you can leave the solution in the comments down below. Trust me, even after 10 years from this video, I'm posting this so 17 January 2020, and I'll be posting maybe some days later. Okay. Well, maybe after 10 years, I will still check your comments and make sure I reply to you. So for this next one, luckily you have one already. So we have one. Then we'll start with from here. You have a 0. Oof, what am I doing here? A 1. Since we have a 0 here, we embed 1. Come here. 0, 1, 1, 0. Exactly the same thing. Okay guys, that's all for this video. Thank God it was a short video. Please, if you're new to the channel, consider subscribing. And if you're an all partner, please let's discuss a bit. Come be friends on Facebook. I'll try to leave my contact number on my WhatsApp contact number. And you can just check my Facebook. I also leave my Facebook link in the description below. So we can discuss and share more ideas, Science, nobody in science knows a lot of things. It's all about sharing information and learning from one another. You can also follow me on Facebook and Instagram. I'll leave the links in the description below. Okay, we'll see you in the next video.